is our multi-touch table, and we use two Epson high-def projectors. You can see one here, and we have a matching one on the other end. And then the light from each projector is driven down here, and it bounces off of a mirror on each side, and then back up to our tabletop, which consists of a piece of acrylic in which we have our infrared lights all around the edge diffusing inward, and then we have a special layer of polyacrylic material on the top that gives a very good feel with your finger and allows you to move your finger around very smoothly, and also will diffuse the infrared light from your finger downwards, and then that light is then picked up by any one of these cameras down here. And we have two setups. So one of our setups has a single camera here in the center with a fisheye lens. And we have another setup that we're working on where we have 4 cameras for each one for each quadrant, and that allows us to do higher resolution and faster tracking because we can send one of the images for processing to each of the cores on our quad-core processor. So this is RENCI's multi-touch table, and what this allows us to do is bring our applications and data into an environment where multiple people can collaboratively work in the same application and data space. So the actual hardware here is a projected display that we bathe in infrared light. When you put your fingers down on the table, that infrared light is reflected off of your fingertips and then picked up by cameras underneath. Our touch engine then generates touch events which allow you to move the map around and interact with the application itself. This application in particular is a RENCI-generated urban growth simulation of the Charlotte region. So what they did was they went and they looked at the last 30 years of growth and where it occurred. Then they tried to predict the next 30 years of growth. And so what this application allows you to do is go in and select areas and examine what kind of growth has occurred there and what's predicted to occur there. So I can do something like I want to select the city of Charlotte. And for that, I will get this probe interface that shows me just what's going on in that local region. So here I'm seeing a graph of how much land is left undeveloped, and we can see that there's virtually no land left after 2030. And there's other visualizations in here as well. Now what I can do, and what makes this very powerful, is I can start looking at many regions at once. So perhaps I want to see the relationships between Charlotte and a lot of the suburbs. So I can put some of these together. So here I can add Concord and Kannapolis along Interstate 85 to the north. I can add, say, Gastonia and the other cities along 85 to the south. And then I can add together some more groups of suburbs in each direction. And then for each of these, I get another picture into the data. So I can then compare these visually, or what I can do is I can ask for a direct comparison. So we can do that. And then I'll say put all of these together into one. And now we have a single interface that allows us to see comparisons just between all of these regions. And so this one here is showing you the number of acres that were converted during each of the time steps for this study. And so you can see the various peaks in development as well as how the pattern of trail off in development is over the next 30 years.